Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. I am Dr. Prabal from IIT Kanpur. We have covered various topics in the course till week 4 in the course, like we have introduced what is artificial intelligence, what are different kinds of logics, what are expert systems, and what are different kinds of searching and sorting algorithms. Now we will start looking at the other foundations of the artificial intelligence, and we will try to give examples from the industrial and management engineering domain. So the agenda for today is we will start with the foundations of machine learning, and we will start by learning what is learning in AI, in artificial intelligence. So the agenda for today is what is learning, then what are the different types of learning, then what is machine learning, then we will look into what are the different kinds of machine learning techniques, so types of ML. Then we will introduce a complete roadmap of performing ML operations on a dataset. So some of these topics from the types of ML are already covered in the course briefly, but we will try to dive deeper into these kinds of algorithms, and we will also look into the examples of all of these algorithms one by one. So let us start by learning what is learning in AI. So this is nothing but process where a system improves its performance given task through experience. So breaking out this statement, the learning in AI is not just about memorizing data. So what it is? It's about making a lasting impact which is useful change to the system's internal state. Okay, so system can set to learn from an experience when its performance can be denoted by P, when its performance P in a task can be denoted by T, gets improved by this experience. Experience can be denoted by E. So when a system gets an exposure to a particular experience E, and its performance get improved in a task T, then we can say that it is a learning process and the system has learned something useful, right. So, this is a very abstract way of telling what is a learning. Now, experience can be data or integration a system gets exposed to. So, this could be a training data set. A task can be a specific problem that needs to be solved by the system. So, there are many classical examples of particular task in an artificial intelligence systems, like one of those is prediction of housing prices. Okay. The last thing that we have used to define this learning process is the performance. So, now we have defined what is a task, what is an experience. Now, how to evaluate the performance of the system after learning something new. So, this can be done by using a metric that can be used to evaluate success. So, any kind of metric like accuracy or mean scores or mean squared errors, also known as MSE. So, these kind of metrics can be used to evaluate the performance of the system. So, there are three major things here: experience, task and performance. Okay. So, moving forward, what are the different types of learning? So, there are majorly two different types of learning. These are inductive learning or deductive learning. So, let us first get introduced to what is inductive learning. So, it is nothing but learning by observing specific examples and inferring a general model using these examples. So, what systems do here is system finds correlation or patterns in the data. And how it will help? But how our system is performing this finding correlation and patterns in the data is important here. That is how inductive learning is defined. So, what it does is it identifies these patterns without explicitly told about these patterns. So, these kinds of systems are nothing but pattern recognition systems that work on their own by utilizing different kinds of data sets, and these kinds of data sets are usually very large. So, what is the outcome of these learning systems is we get a trained model that can generalize to a new unseen data. Okay. Now let's understand what is a deductive learning. So these are the two major branches of learning in AI. In these kinds of systems, the system cannot create a new rule automatically, like what we have seen in inductive learning. So how does the system work? And the system acquires new knowledge or rules from a human expert. Okay. And the outcome of these systems are, we will get a system which is more comprehensive and capable of what? Capable of knowledge base. So it allows accurate logical deductions. So when we are talking about expert systems, we are actually performing the deductive learning in those artificial intelligence systems, right? Now there are some more differentiations between these two learning types. Like, let's learn more about inductive learning. We can also define these kinds of learnings by stating that it is a bottoms up approach. So what does that mean is, the system learns to make generalizations from specific instances or observations. So it is nothing but we have shown some observations to our system, and it tries to learn what these observations are, what are the relationship between different observations, and these kind of things. So whenever a new observation comes, our system should perform in a way that it can learn new things and adapt to those new instances. Okay. So we can also see an example of inductive learning by saying that a baby learns initially using inductive learning. So how is this statement true is, like, a baby when tries to learn what are different things and how different things are different from each other, what are hot things, what are cold things. So what baby does is, baby tries to touch everything, and whenever it finds something hot, he or she gets repelled from that object and tries to create different learning observations inside their own system. So this is how inductive learning works in humans, right? So inductive learning is the foundation of supervised machine learning. Now, deductive learning is just the opposite of inductive learning. It is a top down approach. And how it works? It applies a set of predefined general rules to a set of specified cases. Okay. So a real life example of these kinds of systems is lawyers. So lawyers use deductive learning. Okay. So how do they do this? They start with a known law. So this is a general rule that is applicable by the law governing bodies. Then their second step is they gather facts for a particular case. So these are specific observations that we talked about earlier. And in the last step, they logically deduce whether the law was broken or not. Okay, so these kinds of systems, these deductive learning systems, these are the basis of expert systems. So we have already learned some of the expert systems in this course, right? So these are the foundations of learning. So chess playing AI is an example of predefined rules about legal moves of the game. So those AI systems that are creating chess AIs, they first understand what are the different rules of the game, and then they try to create those rules into the artificial intelligence system so that they can play with humans or with other AI systems, right? Now, one good thing about these kinds of deductive learning is they are highly reliable and explainable. So when we are using inductive learning systems, we don't know how the system is learning about new things, but since we are already defining pre-configured rules in the deductive learning systems, we get to know how the system is performing with each step, right? So that is why they are highly reliable and explainable systems. Now, when to use inductive learning? So use inductive learning when rules are unknown. Okay, so what does this statement means is when the relationship between input and output is unknown to a human expert, then we should use these kinds of inductive learning systems, right? So this type of systems excels, these systems excels when the data has many features. Okay, so these kinds of systems are also known as high dimensional data systems. Okay, so the example of these kinds of high dimensional data systems is an image recognition problem. So when we try to analyze a particular image into, let's say, a cat or dog, so we have, let's say, 1000 different kinds of images with the cats and dogs, and we try to label all of these uh, images into cat versus dog. So every image is divided into different pixels. So we have a very high amount of data of pixels, and we need to identify learning in the system that with a particular combination of pixels and their intensities and their color, we can identify whether the animal is a cat or dog. So this is the image recognition problem that is a part of inductive learning systems. Now there are some issues with deductive learning systems as well. Since it is highly explainable system, we must know when not to use. That is why we are learning about what are the different kinds of issues in deductive learning. Okay. So the challenge is manually creating a lot of rules. So let's say you want to automate the complete work process of a lawyer in his firm. So what you want to do is you need to create pre-configured rules for all the laws, and then the system will try to identify when the law is broken or not. So this is a very cumbersome task to create pre-configured rules for all different kinds of combinations, right? So this is the first challenge of these kinds of learning systems. Further, these systems are brittle. So as we have already discussed that why we are saying them as brittle, because they can only work for a pre-configured rules. Okay, and lastly, these systems are not scalable. So for a very large kind of problem, we cannot create different kinds of rules because they can be infinite. So that is why we cannot use deductive learning in those cases. So thank you.